Alright, what's going on? This video we're going to look at derivatives using the product and quotient rule. Alright, so let's go ahead and get started. So here you can see we've got the formulas for the product and the quotient rule. So the product rule, if you have two functions multiplied together, so we've got u times v, then it's the derivative of u times v plus the derivative of v times u. I think an easier way of remembering it is it's the derivative of the first function times the second function plus the derivative of the second function times the first function. See, here's your first function, here's your second function. So it's the derivative of the first times the second plus the derivative of the second times the first. And that's the product rule. Now for the quotient rule, you've got a numerator and you've got a denominator. U is your numerator, v is your denominator. So it's the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator, and then all of that over the denominator squared. So in the last video, we learned the power rule. You've got to know that. This video, product and quotient rule, you've got to know them. If you don't know them, you're not going to be able to work the problems. And then in the next video, we'll do chain rule. Those four you have to know in order to take derivatives. You've just got to know them. If you don't, you're not going to pass your calculus class. All right. So let's get started on some examples. So here it says find the derivative. And notice here, we have two functions, x squared plus 2 and 3 minus 2x. So this is your first function, here's your second function. So the derivative, f prime of x, is equal to the derivative of the first, which is 2x. The derivative of x squared is 2x, derivative of 2 is 0. So that's the derivative of your first function times the second function, 3 minus 2x. And then it's plus the derivative of the second function. So what's the derivative of this? Derivative of 3 is 0. The derivative of minus 2x is negative 2. So that's the derivative of the second function times the first function, x squared plus 2. And then all we have to do is clear parentheses and combine like terms. So f prime of x, 6x minus 4x squared, and then negative 2x squared minus 4. And so your derivative is, let's see, that's going to be negative 6x squared plus 6x minus 4. And there's your derivative. Now, I know what you're probably thinking. You're probably thinking, well, why couldn't I just multiply that out, full it out, and then take the derivative? Well, you can, and let's go ahead and do that and see what happens. So this would be f of x, so I'm going to multiply the x squared to each term and then the 2 to each term. So that's going to be 3x squared minus 2x cubed, and then plus 6 minus 4x. And so that's going to give me f of x is equal to negative 2x cubed plus 3x squared minus 4x plus 6. All right, so we multiplied it out and we just basically we rearranged the terms. We couldn't combine anything. So now that we have it multiplied out, let's take the derivative. So I get f prime of x is equal to, so what's the derivative of this? Negative 6x squared plus the derivative of this, 6x, and then the derivative of this is minus 4, derivative of 6 is 0, and you can see you get the same answer either way. Now, let me give you a recommendation. When you're working on product and quotient rule, yes, you can multiply this out, but don't. Use the product rule on it, okay? You need to get practice using the product rule. All right, because later on in your calculus course, or other problems that you work, you're not going to have a choice but to use the product rule. For instance, if you have a problem like this, say x squared times sine x, you have to use the product rule there. See, x squared is your first function, sine is your second function. There's nothing you can multiply and then just use the power rule. You have to use the product rule. So while you're working these problems here, use the product rule. All right. And then, as you get more and more into calculus and you get better at it, if you want to multiply that out, that's fine. But for now, use product rule. All right. So let's look at this. So here's my first function. Here's my second function. So y prime, the derivative of the first, so derivative of 3 is 0. Derivative of negative x is minus 1. Derivative of minus 2x squared is minus 4x. So that's the derivative of this first function here. And then it's times the second function. So times x to the fourth minus x. And then we have plus. And then it's the derivative of the second. So the derivative of x to the fourth is 4x cubed minus the derivative of x is 1. So this is the derivative of the second function, and then times the first. So times 3 minus x minus 2x squared. And now we've got to multiply and combine like terms. So I get y prime is equal to, so let's multiply this. This is going to be negative x to the fourth plus x minus 4x to the fifth plus 4x squared. All right, so that's multiplying this out. Now I've got to multiply this out. So I'm going to take the 4x cubed, multiply it times each term, and then the negative 1, multiply it to each term. So that's going to be plus, that's going to be 12x cubed minus 4x to the fourth minus 8x to the fifth. And then multiply the negative 1, so that's minus 3 plus x plus 2x squared. And let's just hope I didn't miss a sign somewhere or make some kind of stupid mistake. So let's combine our like terms. So that's going to be negative 12x to the fifth. All right, so that takes care of my x to the fifth. Now let's look at the x to the fourth. So that's negative 1 minus 4 is negative 5x to the fourth. And then we've got x cubed right here. So that's plus 12x cubed. And then let's look at the x squareds. That's 4x squared plus 2x squared is 6x squared. And it's plus 6x squared. And then we've got our x terms, so that's going to be x plus x is 2x. And then our constant terms, minus 3. Minus 3. And there's your answer. All right. So let's move right along. Okay, so now we have a rational function. We want to take the derivative. Here we have to use the quotient rule. So the first two examples we worked, we used the product rule. Now we use the quotient rule. All right. So what does the quotient rule say? F prime of x is equal to, so remember, it's the derivative of the numerator. So what's the derivative of the numerator? Well, that's negative 2. So there's the derivative of the numerator times the denominator, x squared plus 2, minus the derivative of the denominator, which is 2x, times the numerator, 3 minus 2x. And that's all over the denominator squared. All right. Now, it's important here that when you do the quotient rule, it has to be the derivative of the numerator first. So the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator. And now we clear the parentheses, combine like terms. And so that's f prime of x is equal to negative 2x squared minus 4 minus 6x minus 4x squared. And that's all over x squared plus 2 squared. And so we're going to get f prime of x is equal to negative 6x squared minus 6x minus 4 over x squared plus 2 squared. All right, so the question that's asked quite a bit when we do the quotient rule is, do I need to multiply that denominator out? In other words, would I need to rewrite the denominator as x to the fourth plus 4x squared plus 4? Write this instead of this. And the answer is no. Don't multiply it out. It's not wrong if you do, but leave it like that. Okay? It'll benefit you later on in your class when you start graphing these things, and we need to see when the denominator is 0. Of course, this denominator will never be 0, but that's not going to always be the case. But yeah, just leave it in parentheses, squared. Okay. All right, so let's look at the next problem. We got another quotient rule. So I've got y prime is equal to, so it's the derivative of the numerator, so that's going to be 9x squared minus 1. So there's the derivative of the numerator. And then that's times the denominator. So times 2x squared minus 5x plus 4. Right? So derivative of the numerator times the denominator. And then that's minus the derivative of the denominator. So the derivative of the denominator is 4x minus 5 times the numerator. So times 3x cubed minus x. So this is the derivative of the denominator times the numerator. And this is all over the denominator squared. Okay? And now, we got to multiply all this out, combine like terms. Okay? So we get y prime. So let's multiply this out. This is going to be 18x to the fourth minus 45x cubed plus 36x squared minus 2x squared plus 5x minus 4. Minus. Now, this is where you want to be careful. Okay? So I've got to multiply this out. Okay, so let's do that. That's going to be 12x to the fourth minus 4x squared minus 15x cubed plus 5x. And that's all over the denominator squared. Okay? And I'm hoping I didn't make a stupid mistake somewhere, missed a sign, or did an exponent wrong. But, stuff like that happens, and it may happen to you also. It happens to me sometimes, even when I'm teaching class. Okay? You just take your time when you're multiplying all this out. Now, hopefully you're sitting there thinking, well, he didn't do that right. Okay? So what's missing here? What am I missing? Well, it's minus this whole thing right here. So it's minus, and you've got to put this in parentheses. Okay? You've got to put it in parentheses. So now, yeah, we've got to spend another step. We've got to do a step and just distribute that negative. So that's 18x to the fourth minus 45x cubed plus 36x squared minus 2x squared plus 5x minus 4 minus 12x to the fourth plus 4x squared plus 15x cubed minus 5x. And that's all over the denominator squared. All right, so let's combine like terms. So I have y prime is equal to, so let's start with the largest exponent. So 18 minus 12 is 6x to the fourth. Now let's go to cubed. So that's negative 45 plus 15. And that's going to be, what is that, minus 30x cubed. Okay. And now let's go to the x squared. So that's going to be 36, 34, 38. So plus 38x squared. Now let's go to x. That's going to be 5 minus 5 is 0. And then the constant term, minus 4. So minus 4. And that's over 2x squared minus 5x plus 4 squared. And there's your answer. So you can see with the quotient rule, and even sometimes with the product rule, as you'll see, I think in the next video when we do a product rule with the chain rule, I mean, it can get kind of nasty with the algebra. Okay, that's just going to happen. Okay, you're not going to get around that. Well, I take that back. There is a way that we can actually find that a little bit easier, but that's later on. We've got to learn some other stuff before we can do that. But for right now, quotient rule, yeah, it's going to get messy sometimes. All right, so let's look at this next example. It says the voltage V across a resistor in an electric circuit is the product of the resistance and the current. If the current I in amps varies with time t in seconds according to the relation I equals 5 plus 0.01 t squared, and the resistance R is equal to 15 minus 0.1 t, find the time rate of change of the voltage when t equals 5 seconds. So what do we need? Well, we need the function for the voltage, okay? And then we want the time rate of change of the voltage, okay? So we need the function for the voltage, then we need to take the derivative of that. Well, they don't give us the function for the voltage, do they? Well, but they do tell us something. It says the voltage V across a resistor in an electric circuit is the product of the resistance and the current. So it's the resistance times the current. And so I get V is equal to 5 plus 0.01 t squared times, that's the current, times the resistance, 15 minus 0.1 t. And no, it doesn't make any difference which one you write first. Okay? All right, so let's take the derivative. So we get V prime is equal to the derivative of the first, which is 0.02 t, times the second, which is 15 minus 0.1 t. All right, so this is the derivative of the first function times the second function, plus the derivative of the second function, which is negative 0.1, times the first function, 5 plus 0.01 t squared. All right, so now all we have to do is clear the parentheses, combine like terms. So I get V prime is, so let's see, 0.02 times 15, that is going to be 0.3 t minus, and then 0.02 times 0.1 is going to be 0.002 t squared. minus, and that's going to be what, 0.5. And then we have 0.1 times 0.01. That's going to be minus 0.001. And so this is going to give us v prime is negative 0.003 t squared plus 0.3t minus 0.5. And there's your derivative. Now they want to know the time rate of change of the voltage when t equals 5 seconds. So we just evaluate the derivative at 5. And so that's going to be v prime of 5 is equal to negative 0.003 times 5 squared plus 0.3 times 5 minus 0.5. And so this gives us, negative 0.003 times 25 plus 0.3 times 5 minus 0.5. And that is going to give us 0.925 amps per second. And so there's your answer. All right. All right, so let's look at the next problem. Got another application. All right, so it says a computer using data from a refrigeration plant estimated that in the event of a power failure, the temperature T in degrees Celsius in the freezers would be given by T equals 2T, or capital T would be 2T over 0.05 T plus 1, and all of those are lowercase t's, minus 20, where T is the number of hours after the power failure. Find the time rate of change of temperature after 6 hours. All right, so they're wanting us to find the rate of change, so we've got to find the derivative of this, of T, capital T. So we've got T equals 2T over 0.05 T plus 1 minus 20. So the derivative, well, here we have to use the quotient rule. So it's the derivative of the numerator, which is 2, times the denominator, 0.05 T plus 1, minus the derivative of the denominator, which is 0.05 times 2t, and this is all over the denominator squared. And then don't forget about this 20 out here. If you do forget about it, you're in luck because the derivative of 20 is 0. But you are taking the derivative of this 20, which that's 0. All right. All right, so now let's clear parentheses and combine terms. So T prime is, so we've got 2 times 0.05, that's going to be 0.1T plus 2 minus 0.1T over 0.05T plus 1 squared. And so T prime is 2 over 0.05T plus 1, and all of that squared. All right. All right, so now what do we have to do? What do we have to do here? Well, we've got the derivative, so now we just plug the 6 in. And so T prime of 6 is 2 over 0.05 times 6 plus 1, and that's squared. And so that is 0.05 times 6 plus 1, and we're going to square that. And then I've got 2 divided by that, and that's going to be 1.2 degrees Celsius per hour. That's how the temperature's changing. All right, so far this isn't too bad. All right, so let's look at this last problem. So it says the stress S on a hollow tube is given by S is equal to 16 dt over pi times d to the fourth minus little d to the fourth, where T is the tension, capital D is the outer diameter, little d is the inner diameter of the tube. Find the expression for the instantaneous rate of change for S with respect to capital D, with the other values being constant. Okay, so it'll be a little more, it's a little more difficult, but you know, it's not too bad. All right. So for this problem, how do I want to go about working this one? Well, you know, it's just remember the capital T and the little d are treated like numbers. They're treated like numbers. The capital D, that's our variable. That's like our x. See, S is like the y, capital D is like our x. So let's go through this one slow, finding the derivative. And that's all they're wanting us to do. They just said find the expression. So they just want the derivative, and we don't have anything to plug in. They didn't give us anything to plug in. All right, so remember, it's the derivative of the numerator. Okay, so what's the derivative of the numerator? That's going to be 16t. Remember, d is your variable. See, d, let me just write it over here. This is your variable. So the 16 and the t are like numbers. Okay, so what if we had 5d? Well, what's the derivative of that? 5. What if we had negative 6d? What's the derivative of that? Negative 6. So what's the derivative of 16 dt? Well, the 16 and the t, that's like your 5. That's like the number in front. So we got d to the first, so the derivative is just the number in front, which is 16t. Okay? And then that's times the denominator. So the denominator is pi times d to the fourth minus d minus little d to the fourth. All right. Now, that's minus, okay, minus the derivative of the denominator. Oh, I'm sorry. Yeah, minus the derivative of the denominator, because we got the derivative of the numerator here, 16t, times the denominator minus the derivative of the denominator. Well, the only variable here is the capital D to the fourth. That's a constant. That's a constant. What's the derivative of this? That's going to be 4 pi d, d cubed. You see that? That's the derivative of the denominator. Look at it this way. If we distribute that pi, that's pi d to the fourth minus pi little d to the fourth, right? If we distribute the pi, well, what's the derivative of this? 4 pi, the 4 comes down, subtract 1 from the exponent, and then what's the derivative of this thing right here? That's just a number. Little d is a constant. And so what's the derivative of that? 0. Okay? And then that's times the numerator, 16 dt, over the denominator squared. Okay? And so I get s prime. So what I need to do here is I need to distribute, don't I? Well, you know, I say distribute that, and let me say this. Yes, you can distribute that. But let me show you this. So instead of instead of distributing, look at this. Let me circle this. You see this 16t and this 16t right here? We can factor that out. That's a common factor that we can factor out. Okay, so let's do that. Well, I'm sorry. Let me rephrase that. We've got a 16t pi. You see that? I've got a common factor of 16t pi. So that's going to be 16t pi times. Now look, when I pull the 16t pi out of here, I'm left with d to the fourth minus d, little d to the fourth. That's what I'm left with there, minus, and then when I take this out, I'm left with 4d to the fourth over pi squared times d to the fourth minus little d to the fourth squared. Okay, you see that? See, when I take out the, look, we're taking out the pi, the 16, and the t. That's what we're pulling out of each one. So I'm just left with this. That's right here. And then minus, and then I'm left with 4d cubed d. D cubed times d is d to the fourth. All right. And so I'm left with s prime. Oh, and here I squared the pi and then squared this. Okay. All right. So I'm left with 16t pi times, and that's going to be what? Negative 3d to the fourth minus little d to the fourth over pi squared times d to the fourth minus little d to the fourth squared. And then, you know, you don't really have to do this, but, you know, to make it look a little nicer in here, factor that negative out. And so I'm going to get s prime as negative 16t times 3d to the fourth plus little d to the fourth over, now you're probably asking what happened to that pi? Pi and pi squared cancel. We're left with pi to the first. And so that's pi times big D to the fourth minus little d to the fourth squared. And there's your derivative. Okay. So that one was a little more involved because you had a bunch of letters in there. But remember, in this one, the only variable was the capital D. All the other variables were treated like constants. All right, and so, yep, that's the last problem. So there you go. There's product and quotient rule. Okay, so I hope this video helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I will see y'all in the next one. Later.